Today, we're going to be talking about what it means to create production ready containers. In particular, what you as a developer need to know in order to secure your container. My name is Evan Harris, and I am on the Slim.AI engineering team. I've been working on software on top of containers for the past couple of years, particularly in the JavaScript and Golang ecosystems. I'm quite passionate about making the web more accessible, but also improving the developer experience for new and aspiring developers. In my spare time, I enjoy developing Obsidian plugins, which is a knowledge management system. When I'm not working, you can usually find me reading about climate change, cooking, rock climbing, or hiking. What do we do here at Slim.AI? For the most part, we're focusing on building secure containers faster, and we really want to help developers build safer cloud native applications with less friction. In order to achieve this, we're leveraging an open source project that you can find on GitHub called Docker Slim. And the Slim SaaS platform leverages Docker Slim in order to help developers decrease the overall size of their containers as well as their vulnerability count. What does it mean to create a production ready container? While it might be simple to create a hello world containerized app, it is completely different to take an application all the way to production. So today we're going to use a simple Node.js example to demystify what's really necessary in order to make a container production ready, as well as some common best practices to help you secure your containers. We're going to focus on three key optimization takeaways: image size, build speed, and security. Generally speaking, smaller images are safer. So if you have a massive code base that you only need a couple of functions to actually run your new application, there's likely a lot of cruft that you can cut out. And by getting rid of this extra code, you will probably be reducing the attack surface of your application. As a developer, it's very important to have sufficient build speed as well. When you know exactly what you have to have inside of your container, you can decrease the cycle time in your dev loop and just iterate faster. And no matter how you actually build your containerized application, you always have to pass security protocols in order to make it all the way to production. What's the challenge with containerizing a application? It can really take a long time to get through compliance, as well as the other gotchas that it takes from taking a greenfield application all the way to a containerized application in production. So what do you do about this? We're going to focus on container image composition, but there's a couple other pieces that you may want to consider when containerizing your application. The first of which is the operations plane. If you're going to do one thing here, it would be logging. In particular, if you're able to use structured logging, this makes it much easier to, say, leveraging a JSON format, integrate with current container logging tooling. A second piece, which for the developer quality of life is very important, is optimizing your build and deploy times. So when you want to add a console log to debug a problem locally, or in your test environment, or in your production environment, how long does it take for you to see that log at each of those stages? Another piece that is a little bit more challenging and really infinitely complex is security. And we're not going to focus on it too much today because it really requires a lot of domain knowledge as well as typically high levels of manual intervention. This isn't to say that it isn't important, though. If you're going to do anything with secrets in terms of trying to productionize your containerized application, the first of which is just don't embed your secrets directly. And the second is don't store your secrets in environmental variables. So what does it mean to slim a container? Slimming refers to optimizing and minifying your Docker containers, which could reduce them by up to 80%, which once again will probably decrease the attack surface of your application. Today we'll be looking at a hello world Node.js example. Here we have a very, very simple Node application, and let's go ahead and take a peek at what a Dockerfile for this Node app could look like. This is a very simple boilerplate Dockerfile that you could find just by querying for a hello world Node.js Dockerfile on Google. How can we make this better? This example Dockerfile is certainly not production ready, and nor is it meant to be. This is really made for a developer just trying to get started, either with Node or Docker or both at the same time. So if you want to start with this boilerplate and run all the way to production, there's a couple of good to know, as well as a few have to know techniques to improve your build time, security, and the reliability. The first of which is setting a user. In this example, you can see there are no user commands anywhere within this Docker file. What this means is that Docker is running all build and subsequent commands as the root user. So what do you do about this? Here we make a single line addition of user node. So for a Node.js application, the user is just node, and we can explicitly invoke this in a Docker file. Let's go ahead and jump over to the Slim.AI Docker desktop extension and take a peek inside of a container that leverages a user of Node. So I built an image on my machine recently called no cache clean with just a tag of latest, and it's not pushed up to any registry, so it's just local. Let's go ahead and look inside of this container and see what we have. And we can go ahead and take a peek inside of the files, but I'm really just curious to confirm that the user is who I believe I set it to in the Docker file. And there, to find that out, we can take a peek at the overview. And as expected, we see a user of Node. So I performed this singular line addition to my Docker file of user Node, and now we see that the user is indeed Node. Just a single change, but marginal improvements. And we perform quite a few of these, and over time, you eventually end up with a more production-ready container. Jumping back over to the presentation, another way that you can improve your container is by pinning a version. In this example Dockerfile, we are using a latest tag in the first line where we say from node latest. And what this means is that if I ran docker pull node latest today versus in 3 weeks or a month or 6 months, I ran docker pull node latest, the single source of truth across two of these images, there isn't one. And what this means from a reproducibility perspective is my tester who might run docker pull node latest on a different day than me will likely see a very different result, or they could see a very different result in the functionality of our application. So what do we do about this? You can pin both a major and a minor version. And this helps avoid the introduction of breaking changes. So instead of from node latest, here we now specify from node 16.14.2. Let's go ahead and take a peek inside the extension again and compare these two images and see what's different inside of them. So I have a node latest image, and I would like to select it for comparison. And let's compare it to node 16.14.2. And we have some differences in the file system, which if I really wanted to get into the weeds, we could go and explore. But I'm more curious at a top level what's different between these two images. The first of which is the difference in the base OS. So we see a shift in what version of Linux we are using, pretty significant. A kind of minor change in size, but still not negligible, about 80 megabytes. And here is really where we could see a big difference in application functionality. We jump from a Node version 17.9.0 to 16.14.2. And over time, you could see how this could really create problems for you if your Node version is shifting under your feet and there are not other constraints within your Node application to enforce a particular Node version. Just something to be aware of. Some other changes that could be interesting are changes in the binary count, as well as differences in size. And depending upon exactly what environment you are running your container in, you might find over time that using latest can bloat your system as opposed to simply having confidence in the base size of the image that you are working with. A way to improve the build and deploy time could be leveraging a pattern called layer caching. Here, we only have a single copy command where we copy the package.json, the app.js to a particular location in the container. And the way that Docker works is it leverages sequential layer caching. So a way that you can improve your build time is by breaking up commands. Here, rather than doing the copy command of both the package.json as well as the app.js in a single line, we break them out into two separate lines. So why do you do this? In that scenario earlier, where we talked about adding a new console log to your app.js file to perform some debugging, every time you wanted to make a change like that, we would only, in this version of the Dockerfile, we would only have to rebuild that layer. This is opposed to the previous version of this Dockerfile, where every single time you change the app.js, we would also be rebuilding the layer with the package.json. And the challenge here is that layer contains the run npm CI command, which means if you have a lot of dependencies, you're going to be waiting basically your entire install time every single time you want to add a console log. So this is a very, very important change to leverage if you want to cycle quickly using containers. Take a peek at another potential way of improving your containerized node application. Let's look at an example extension to your NPM workflow. So while it might not save a lot of space depending upon your application, cleaning the NPM cache is basically just like tidying up a little bit before deploying this container. And maybe you don't have a background in exactly what this command performs, so you want to figure out whether or not it could introduce some breaking changes. So let's go ahead and take a peek in the Docker Desktop extension again and see what differences we have between the two images. So we looked at the no cache clean image earlier, but we also have a cache clean image. And effectively, one of these images has the cache clean command and the other one doesn't. And let's go ahead and compare the two. So we have a much smaller spread in the number of changes that we have. But for now, let's just go ahead and jump over to the image metadata diff. So we don't see a lot of changes in base OS, ports, or size, which is good. We only added a single flag to an npm command, but we see a slight change in UTF-8 count, as well as a change in UTF-8 size, and it is pretty insignificant. And what this tells me is, while I could make this improvement to my application, given the simplicity of my app.js and the singular dependency of an express, there really isn't much rationale for doing this at this point in time, especially if I don't fully grasp the potential negative effects of cleaning my cache. Something that I might revisit in the future is adding this command, but for now, maybe I don't see sufficient justification for adding it to my Docker file. Another way that you can improve your containerized applications is by using alternative base images. Generally speaking, this is the easiest way to get to a smaller container. Now, the downsides, quite a few, but could be worth the trade-off depending upon your scenario. For the most part, you're going to be inheriting all of the responsibility for installing everything you need. If you're using a Node latest or Node 16.14.2, you probably don't have to install your developer tooling or your time zone data. But if you want to take advantage of Alpine, you are now going to be responsible for installing all of those items. A secondary challenge to this, for those of us who are quite used to having significant Stack Overflow resources, is the smaller ecosystem and fewer examples on top of Alpine. And a third and still very significant challenge is the compatibility issues. Over time, you will find some just additional maintenance challenges of building on top of an Alpine base that you might be okay with if it is a sufficient savings to your smaller container, but it is something to keep in mind if you are going to try to make this hop. Let's go ahead and compare the Node 16.14.2 image to the Node 16.14.2 Alpine image. And let's see how much of a difference there really is between the two. So first off, we see a huge spread in the number of changes, some additions, some deletions, and some modifications, predominantly deletions, which does make sense, right? We're going from a Ubuntu 16.14.2 to an Alpine base. And let's go ahead and take a peek at the top level differences here. So we're going from Linux 10, which we did see in one of the other comparisons, to Alpine Linux. And here, this is really where we see the significant savings. we go from an uncompressed size of over 900 megs to just over 100 megs. And this is very, very significant. If you are running and storing quite a few of these containers over time and paying for data in transit, you will see a pretty significant difference here. Now, to get a peek at what else is different between these two containers, which really could tell you, hey, what responsibility will I as the developer pick up by switching to Alpine? You know, saving 800 megs sounds pretty nice, but what's the catch? We see quite a few different changes in our certs, as well as a massive, massive change in the binary count. We go from almost 9K to 27, as well as a very significant size difference in the overall binary size. A similar change for UTF-8 count, going from almost 17,000 to just 2,500. Now, what this means is, while you might instantly save a lot of space, what does your application need in order to still run? And you do need to know exactly that in order to be able to make the switch from really any larger base image over to Alpine. And it could be worth your while. Leveraging multi-stage builds is another way to improve your containerization experience. A primary advantage of this is it reduces your final image size. A downside is that it requires you to have an understanding of exactly what application dependencies your app has and exactly which files you must copy over. In this Dockerfile, in the first line, we see a from ... as builder, and further down, we see a copy from builder. What this allows you to do is split up some of the, call it, installation, scripting, setup, processing into your first stage, the builder stage, from the final container, which is effectively the second block of code here. And while this application is quite simple, so maybe there's not too much of a savings here, you could see pretty significant differences in what ends up in your production image if you don't run all of your setup in your prod image. Like, why do that if you don't have to? But the additional challenge here, as previously mentioned, is your app.js, what does it need to run? If you don't include every single piece that it needs to run in your production image, you're going to have some problems down the line. Using Docker Slim is another way to improve your developer experience building on top of containers. It is an automatic way to create up to 30 times smaller containers. It removes shells, package managers, and other potential vulnerabilities. Now, like any very powerful tool, the primary challenge is that the learning curve is pretty steep. It requires some configuration as well as some tinkering. In this example CLI, you see a Docker Slim build target node app start command, as well as a little GIF of what you might see if you were to run Docker Slim locally. And this project is available on GitHub for anybody to pull down and play with. Let's take a peek at what potential savings you could see with a Node application, building it in a couple of different ways. The first line item here, we have a Node image of 856 megs. And then to jump to the very end, we see a Docker Slimmed Node image with effectively 1/10 the size. So massive, massive savings. In the middle, we have quite a few different other options, the multi-stage build, the Alpine, as well as the no cache. And depending upon which of these paths you choose, and hey, maybe you combine all of them, there's no reason that you can't, you can see different size savings. But the added complexity, as well as the long-term maintenance costs of each of these, is always something to be considered when figuring out how to integrate different tools into your developer experience. The Slim.AI SaaS, as well as the Docker Desktop extension, offers you the ability to analyze, compare, and optimize images. Today, we looked at how we could use the Docker Desktop extension to both analyze as well as compare different images. The optimization piece is currently available on the Slim.AI SaaS, and you can go ahead and take a peek at that whenever you would like. For now, just keep building, and you can find us on Twitter at SlimDevOps. Thank you.